The concentration of the complex ion in each of the following solutions is 1 molar. And which of the concentrations will the concentration of the uncomplexed metal ion be the greatest? All right, now I have a few ways of asking this type of question. The key things that change really are these guys, obviously, and that word right there, and that word right there. Well, dealing that we're always going to have this greatest or lowest, we really are only ever looking at the largest K and the smallest. The other ones are just kind of be useless information, so let's get rid of those first of all. I can do that there. All right, so same question, but now I've got it down to just there's only the 2 possibilities that are even remotely possible. All right, now this one asks about uncomplexed metal and being the greatest. And I'm just going to grab one of these. Doesn't matter which one. I'm going to grab the one on top. And we're going to talk about it so we can see where this goes. All right. Turns out the complex metal, as it's written there, is always the product. So I'm going to rewrite this as a product. And this, as is written here, is the complexed metal. Complex as in it has the other species with it. The uncomplex that this problem is talking about is, in this case, the mercury that was all by itself. Let's see. CNs are each -1. This got to be the mercury 2. And this thing bumped into some cyanides, and now we've got the complete equation. But this is the uncomplexed. All right. But think about it in terms of uncomplex is always reactant, complex is always products. And if we want uncomplex to be the greatest, we want a reaction that favors reactants, therefore a small k. So the small k is what we're looking for. So that tells us that the cadmium iodide gives us our correct answer, as in that's the one that we want, but it's not the cadmium iodide as the answer, because the cadmium iodide is the complex metal. This one wants the uncomplexed, which is Cd2+. All right, now I have 4 different ways I can change this. These bold italics words, I can change them. So we're going to look at the possibilities now. So the first possibility is, let's say I asked for the uncomplex to be the lowest. I still think about this the same way. So I still do have the complexed ion as the product. This one is still made from mercury 2+ and some cyanide, and 4 of these. And this is still the uncomplexed. Alright, but this time we want the uncomplexed to be the lowest. So we want a reaction that goes forward really well, so we want a large K. So our large K is with the mercury, and our uncomplexed ion is the mercury, so our correct answer is the Hg2+. Now, what we can also do is change the uncomplexed word to complexed. Now, general rule of thumb, I'm not going to write the equation this time, I just want you to remember that the uncomplexed metal is always the reactant, turns into a complexed metal as the product. And if I want this to be the greatest, I do want a reaction that that likely goes forward, so we do want a large K. So this is the K that we're looking for, but since it's the complexed ion form, the answer is going to have the ions attached. So it is whatever is written on this thing. And then finally, complexed and lowest. So same general idea. You have uncomplexed metal turning into complexed, and we want the complex to be the lowest. So when we want a reaction that we want a K that favors reactants, So that is a small k, giving us, that's going to lead us to our correct answer. And we want the complexed ion, so the answer is going to be that CdI4 2-. And that's all the possible ways I could ask that question with those species listed. But you're always looking for that small k and large k, and then you just want to figure out which side you're looking at based on if it says complexed or uncomplexed and greatest and lowest.